Hello everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, what I want to do is to go over graphing rational functions. Rational functions meaning if two functions that can be written as a ratio. So how are we going to do that? Okay, let's start. So I'm going to assume that we have two functions, f of x over g of x. And we want to plot that. In order to plot it, there are like 6 steps we have to go through. Not necessarily in order, but you have to understand there are 6 things. What is the first thing, or one of the things we can start with, is to find what we call a horizontal asymptote. And an asymptote is a line that my graph would approach. We'll never cross it, but it can get very close to it. Okay, either horizontal, slanted, or vertical. Okay, the horizontal, sometimes we can cross it, but at the ends, my graph would either go, below or above, but very close to a horizontal asymptote. Okay, but in the middle, it may cross it in some cases. Horizontal, I should say horizontal or slant asymptote. That's the first step. Or the second, because the first may be a vertical asymptote. So either horizontal or slant, not both, and vertical asymptotes. Number 3, I may have holes in my graph. What? Yeah, a hole. And we'll see how we find that. It's so easy. Number 4, you can find the x-intercept, meaning where my graph crosses the x-axis, and y-intercept like we do with straight lines. And the last step is just to take middle points to get it more precise, more accurate, okay? Because sometimes we don't know how the graph is turning. Is it very close to the x and y axes or far? So we can use the calculator and check the value of y at different x values. Alrighty, having said that, that doesn't help me because you never told me how to find these asymptotes or holes. I know how to find the x and y intercept, but what about the others? Okay, so let's look at the first case or the first part that says horizontal or slant asymptote. I have 3 cases, f of x and g of x. I'm going to call that the numerator or simply n, and this is the denominator or simply d. So I don't write a lot and I don't waste your time. If degree, I'm sorry, if degree of d is greater than degree of n, the x-axis, meaning y equals 0, is a horizontal asymptote. So if I'm dividing a square function by a cube function, I don't think it. The x-axis is a horizontal asymptote, and I'm done with number 1. What if the degree of the denominator equals the degree of the numerator? In that case, f of x equals leading coefficient of numerator divided by leading coefficient of denominator is a horizontal asymptote. Nice? Last case, if the degree of the denominator is less than the degree of the numerator, f of x would equal long division of numerator over denominator without remainder. So meaning once you get to the remainder, just ignore it. I truncate it. And that's how you find horizontal or slant asymptote. There is nothing else, either greater than, equal, or less than. 2, values of x that make denominator equal 0 are vertical asymptotes. 3, if both numerator and denominator have the same factor. So x minus 2, x minus 2, x plus 5, x plus 5. Okay? Same factor. Then the, oh, I'm sorry. Yeah, then the x, the value of x that makes the factor equal 0 is a whole. Of course, you can find what y corresponds to that. So which point? If I tell you x is 3, you say, okay, 3, and what is y? You just substitute in the equation and get y. Okay? Number 4, x-intercept set f of x equals 0. 5, y-intercept set x equals 0. 6 is just to take few points to make the graph more accurate. We're done. So let's do some graphing. I have like here 14 problems. The first 4 are simply tells you, they ask you stuff that you will do anyway here. So I'm not gonna do those. I'm gonna ignore them and just concentrate on graphing because we will have to calculate these anyway to accurately draw the graph or to graph the functions. Okay, so let's look. Oh, which problems am I going to do? So let me do 5 and then go to the right and do 8. And then maybe go to the left and do this, and then come to the right, and then go to the left. Or maybe I'll do these 5 if time permits. If it's too long, I will stop. Okay, so number 5, f of x equals negative 4 over x squared minus 3x. Degree of numerator is 0, of denominator is 2, so denominator is larger, the x-axis is an asymptote. What is it? X-axis is already drawn, but I'm going to just add dotted lines so I know that this is an asymptote. Y equals 0. Asymptote. Vertical asymptote. Okay, what makes the denominator equal 0? So I'm going to set these to 0. So I get x equals 0 or x equals 3, right? X times x minus 3 equals 0. So x equals 0 is the y-axis. So these two x's are asymptotes anyway. And x equals 3 is an asymptote. So I found all the asymptotes. Now I find the x-intercept. It doesn't exist because how can f of x equal 0 if the numerator is a number? That means the denominator has to be infinity, that's why it's an asymptote. So it doesn't cross the x-axis, but they get very close to it. Okay. No. Y-intercept, setting those equal 0. So either x equals 0, uh, if I set, I'm sorry, f of x, we said if we set f of x equals 0, you get no. If you set x equals 0, you also get no asymptote. So it doesn't cross the y-axis, it doesn't cross the x-axis. Why? Because if that's a 0, you are dividing 4 by 0 and you are getting infinity. In fact, that's a vertical asymptote, so I cannot cross it. There is no y-intercept. Okay, so I'm done. I just need to know which parts, because I have 6 parts. Is it up or down, up or down, up or down? So we know that this x equals 0. So all what I have to do is to take a value smaller than 0 and see if I get it positive or negative. Because if it's positive, my branch would look like that. If it's negative, it would be looking like that. That's how simple it is. So I'm going to say assume x, I get x equals, say, to the left would be, say, negative 0.1. Just a very small value. I'm not going to evaluate. You can, but I'm not. What I'm going to say is f of negative zero point 0.1 equals. The numerator is negative 4. It doesn't change. Negative 1. So this is, notice this. Let me rewrite it as negative 4 over x times x minus 3. If this is negative 1, then x is negative. And if this is negative 1, negative 0.1, so that also is negative. So the numerator is negative, the denominator is positive, and you divide them, you get negative. What does that mean? It means that to the left of the y-axis, you are going down to negative infinity because you got negative. And since I'm not going to cross the x or the y, then this branch looks something like that. I don't know exactly. That's what I was telling you. At the end, when you are solving, you will get, for example, what is f of negative 2 or negative 1, and get these points more accurately. Here, I'm just showing you the general way to do it. What about just slightly to the right of the y-axis? Let's say f of 0.1. The numerator is negative 4. The denominator is 0.1, which is positive. So I just negative the numerator. I don't care about the value. 0.1 is positive and 0.1 minus 3 is negative. So I get negative divided by negative is positive. So here I'm going up. I can find at 2.9 and 3.1, but guess what? I know I'm not going to cross the x-axis, so that definitely would be going up. It's going to look like the letter U. And as I said, you can use your calculator to see, what is the value, say, at negative 2, at 2 or 1. So maybe it's something like that. And finally, I'm going to take f of 3.1. The numerator is negative 4. If x is 3.1, then this is positive. If x is 3.1, then that is also positive because 3.1 minus 3 is positive. Negative over positive is negative. So here I'm going like that. And since I'm not going to cross the x, then this branch would look something like that, and I'm done. Let's try to see, to plot it and see. Negative 4 divided by x squared minus 3x, close parentheses, graph. Yeah, left branch, U shape, right branch. Okay, so that's number 5. Let's move to number 8. F of x equals x cubed minus 9x over 3x squared minus 6x minus 9. When you have cases like that, it's better to factor them out. Like here also, I could have factored, I should have. X will give me x squared minus 9, which is the difference of two squares, x minus 3, x plus 3. Denominator, I factor 3 out. That would leave me with x squared minus 2x minus 3. I need two numbers that multiply to negative 3 and differ by negative 2. So negative 3 and positive 1. And here I see I have a hole. a hole at 3 and what y? I ignore the x minus 3 terms as if they were not here. And I'm going to say substitute x equals 3 for the rest, because if I substitute here, I get 0 over 0. So just ignore that because that's a hole. It's not part of my graph. So I get 3 times 3 plus 3 is 6 over 3 times 3 plus 1 is 4, 3 halves, or 1.5. So there is a hole at 3 and 1.5. There is a hole here. Okay. Um, okay. We have a vertical asymptote at x equals -1, right? Because that would make the denominator 0. So I have vertical asymptote here, x equals -1. And then I look at uh, the degrees. The degree of the numerator is higher than that of the denominator, so I'm going to use uh, long division. Okay. In fact, I'm going to do long division. I don't care about the x minus 3. So I could divide these. It's no big deal, but I prefer to say x squared plus 3x, sorry, divided by 3x plus 3, right? So x squared divided by 3x is 1/3 x. Multiplied by 3x is x squared. Multiplied by 3 is x. And then I'm going to subtract. So I get 3x minus x is 2x. Then I divide 2x by 3x. I still can divide, and I get plus 2/3, which means I get 3x, I'm sorry, 2x plus 2. Subtract, I get -2. I cannot divide, so that's the remainder. I ignore it. I say slant asymptote at y equals 1/3 x plus 2/3. It's not easy to find where the 2/3 is and the 1/3. So in that case, I would recommend that you use what I taught you before to multiply this equation by 3 and put it in standard form, meaning the x and y on the left-hand side and the constant on the right. So if I multiply by 3 and move the x, I get -x plus 3y equals 2, right? Multiply by 3. So this would be 3y. Multiply by 3, that would be x, but I'm going to subtract x from both sides. And multiply by 3, I get 2. Why? Because now the x-intercept of this line is 2 divided by -1 is -2. And the y-intercept is 2/3. The y-intercept is 2/3 is somewhere here. And the x-intercept is -2. So I'm going to join these 2 points and extend them. In fact, it would be something more like that. Wait a second. Yeah, 2/3 should be lower than. Mm, 2/3 is below. This is 1. I'm sorry, I thought this was 1. So I thought it has to be lower. And it is lower. fact, it's going to be to go through this point. Slightly above the hole. And that tells me that since it's slightly above the hole, then the branch would look something like that. It cannot go from here since the hole is below the line. This is 1.5, and this is 1 2/3. So it's slightly below. And this branch, even without knowing, it's going to go something like that. What about the values to the left? Did we find, we can find the x-intercept and the y-intercept. Oh, we already, these were for this, for the slanted asymptote, but I'm talking about the whole thing. X-intercept is when the numerator equals 0, meaning at 0 and at -3. So -3, and this should have passed through the origin. So that's why I said it's better to use the calculator and get values. It should be more like that. That's when I said you can make it more accurate by taking more points. So just ignore that. And it passes through this point. If you try the y-intercept, you will get 0, right? The y-intercept, when you set all the x's, why didn't we find the y-intercept? Y-intercept should be at 1, not at 0. So no, wait a second. I confused myself by looking at that. Here is the equation. The x-intercept is when this guy equals 0 and this guy equals 0 when x is 0 or x is -3, right? And the y-intercept is when the x's equal 0. Of course, you don't care about that. So you get 0 times anything is 0, so the y-intercept is 0, so it has to pass through the origin. That's what we said. The other branch should come here because I cross at -3, right? So it's going to look something like that. So these are the two branches. And again, that's what I told you. If you have time, I don't. I don't want to keep you. You would take points. What is the value of y when x equals 1 or when x equals -3? And -3, we know it passes through the origin, but -2, is it here or there or below? So that's why you can get it more accurate. But this is the general shape, and that's what they usually test you on. So x cubed minus 9x divided by 3x squared minus 6x minus 9. This is the left branch and this is the right branch. And of course, they don't show you the whole, you can't see it. But if you go to the table, you will see that x equals 3. If I go to x equals 3, you see error because there is a hole there. They don't tell you 1.5 because there is no point there. Okay. Oh, too much. Okay, how about this one? Number 9. I don't think we have time. Well, we'll see, but if it takes long, maybe I'll do only one of these. Seems so easy to, maybe we'll jump to 13 right away. F of x equals 3x squared. I will simplify as we go. So I can take 3x as a common factor, and that leaves you x minus 4. And the denominator, we just did it, x minus 3 times x plus 1. That's easier. Uh, the degree is the same, so there is a horizontal asymptote at y equals 3. When you divide 3 by 1, you get 3. So there is a horizontal asymptote here, f of x or y equals 3. How about the vertical asymptote? What makes that 0 is 3 or negative 1. So negative 1 and 3. Okay. Now, what else after? So vertical asymptotes, x equals negative 1, x equals 3. Find the x and y intercepts. X-intercept when this equals 0, meaning when the numerator equals 0. So either x equals 0 or x equals 4. So it passes through the origin and x equals 4. Okay, how about the y-intercept? I set x equals 0, so I get 0. So it just crosses the y once at the origin. Now we need to know where, in which I have 6 areas. Where are my branches? So if I take x to the left of negative 1, f of negative 1.1, for example, 3x would be negative. Negative minus 4 is also negative. Negative 0.1 point something minus 3 is negative. And negative 1.1 plus 1 is also negative. So when I divide these, I get positive, meaning this branch would look something like that. How about if I am to the right of this, meaning at f of negative 0.9, for example? This is negative 1, so I got slightly higher, negative 0.9. Negative 0.9 would be negative. Negative 0.9 minus 4 is negative. Negative 0.9 minus 3 is negative, but negative 0.9 plus 1 is positive 0.1. So this is negative, meaning my graph to the right of this asymptote goes to negative infinity. Guess what? I'm crossing at the origin. So is it going to go like that and then down? Or like that and keep crossing up? Notice I said in the middle, we may cross the x-axis. I'm sorry, the horizontal asymptote. That is possible, especially that I cross here. So I need to know what is f of 2.9. Is it here, meaning this line would go like that? Or is it here, meaning it crosses and then comes back? So we need to check that. I have to say f of 2.9. 2.9 is positive, but 2.9 minus 4 is negative. 2.9 minus 3 is negative, but 2.1 plus 1 is positive, so I get negative over negative is positive. So yes, my graph is going up like that and then up like that. Again, yes, we can cross a horizontal asymptote in the middle, but at the end, it will approach one of them. Let's look, what if it's 3.1, meaning just to the right of this asymptote, f of 3.1. This is positive. 3.1 minus 4 is negative. 3.1 minus 3 is positive, and 3.1 plus 1 is positive, so this is negative. So I will go from here, and we knew that we have to cross this, so it has to be below, because here it doesn't pass through this point, the x asymptote. So that's how it should look. Let's quickly go and clear that. Between parentheses 3x squared minus 12x divided by x squared minus 2x minus 3. This is the left branch. That's the middle branch. And that's the right branch. Nice? Okay. Oh, let's see which one. We said, should we do this or that? This seems more complicated. Not complicated, but maybe I'll do 13, and then if I see that it wasn't too long, we'll do this one. F of x. And just to simplify, I'm going to take 2 as a common factor. So this is x squared plus 5x plus 6. So x plus 2 and x plus 3, right? Two numbers that multiply to 6 and add up to 5. The denominator is easy. It's similar to the one we did, x plus 2 and x plus 1. A whole at x equals -2. Whole at -2. And if I substitute -2, I get 2 times 1, -2 plus 3, over -2 plus 1 is -1. So at -2 and -2, there is a whole at this point. Let's look at the asymptotes. 2 over 1 is 2, so at f of y equals 2, there is a horizontal asymptote. Y equals 2. What makes the denominator 0? X is -1. So there is an asymptote, vertical asymptote at -1. I'm not writing that just to save time, but you can see. In fact, here I see that there is a branch that comes like that. It passes because the hole is here. So one of the branches, without doing more math, would look something like that. But you can check at, -1.1 or something. As I said, this is x equals -1. So we try f of -0.9, something slightly to the right. 2 is positive. -0.9 plus 3 is positive. -0.9 plus 1 is also positive. So I am here. I'm going to plus infinity. So we know, just if you want to check to see the x-intercept is when this equals 0. So x, when this equals 0, the numerator has to equal 0. So x would be -3. So it passes through -3. You see, it's a little, we drew it closer to 4. So we could have just got this branch at -3. This branch, you see, it has to pass through this point. That's why I should have gotten the x-intercept first. It goes something like that. Okay, how about the y-intercept? Do we have any? So set x equals 0. 2 times 3 is 6 over 0 plus 1, so add 0 and 6. So because we cross here, then this branch should go something like that. Oops. I hope we did it correctly. I was trying to do it fast. Let's clear. 2x squared plus 10x plus 12 divided by x squared plus 3x plus 2 Yeah, so this is above the x-axis going down, and this is coming like that and crossing here. And these are the the asymptotes. I think we have time. We can do number 12. F of x equals x plus 2 over x plus 6. I'm sorry, 2x plus 6. Same, same degree, so f of x equals 1/2 is a horizontal asymptote. 1/2. Oh my God, I don't like the fractions with this small graphing paper. So x equals, f of x, I mean, or y equals 1/2. Okay, how about vertical asymptote? Well, x equals -3 is vertical asymptote because that's what makes this equal 0. So -3, there is a vertical asymptote. X equals -3. I have 4 areas. I need to find the y-intercept is when x equals 0, so you get at 1/3. If this is 1/2, 1/3 is below that, right? 1/3 is less than 1/2. The x-intercept is when the numerator equals 0, meaning x equals -2. So I pass through this point and I pass through that point. That tells me all what I want to know, that this branch would look something like that. And finally, when x is to the left of -3, so f of -3.1, for example. -3 plus 2 is negative. -3.1 times 2 is -6.2, but plus 6, it's also negative. So that is positive, it's going up. So this looks something like that. And again, taking more points, you can make it more accurate. Okay, let's try that. Sorry guys if it's taking too long, but I just wanted to make sure you get it. 2x. I'm skipping some stuff. I hope that didn't confuse you, that sometimes I don't calculate everything. It's just for the sake of time. But you can see that they don't show you exactly where the asymptote is, but as I said, if you say, give me the value of y when x is -3, you will get error because it doesn't reach -3. It's slightly to the left or slightly to the right. Go to the graph at -3, which should be here, you get an error. But at -2, you get 0 because we said this is the x-intercept, and the rest is history. So 6 steps. I ignore the sixth one, the sixth step, just for the sake of time. But we really, the sixth point is to find what is f of -1 or f of -3, so you can get this more accurately than what I did. I just, get asymptote here, asymptote there. If I don't know a specific point, I don't know where to pass. So that's why I said it's better. Of course, if you have a calculator, you open the table and you can find the points and you get it even more precise. Okay, so that was an important topic. I think I will start posting more than one video a day so we can finish before the exam, especially that you need to practice. And I have some practice tests online. So maybe I will start to post them more frequent. I still need to do uh, sequences and series, like arithmetic and geometric sequence and series. We still need to do trig and trig graphs along with transformation. So I think it's a lot. So I will try to do more videos, more frequent, and post them more frequently. So maybe twice a day instead of once. Okay? If you have any questions, please let me know. Otherwise, wish you all the best in your Regents. And until I see you again, I wish you all the best.